Imagine pouring a concrete foundation, right?
Yeah.
One that cures in like 3 seconds, throwing a massive 50-story skyscraper on top of it, and then instantly realizing the crew next door just invented a structurally superior concrete.
Oh, wow. Yeah, that's a nightmare scenario.
Right, like do you tear your entire building down? Do you try to somehow build on top of theirs? That absolute structural chaos is, well, it's essentially the reality of generative AI right now. Welcome to the deep dive. We are thrilled to have you here with us.
Absolutely.
Because, you're constantly bombarded with headlines about the latest AI tools, the shiny new applications, the endless noise of the tech world.
So much noise. It's everywhere.
It really is. But you're here because you want to jump past that surface level hype and get to the absolute bedrock of what is actually driving this revolution. So today, we are focusing our lens on a very specific, incredibly potent grounding source.
Yeah, and it's a really unique one.
It is. It's a mission statement focused entirely on the foundations of generative AI, specifically state-of-the-art research papers and the vital necessity of sharing them.
I mean, it's a fascinating directive because it completely reorients where we should be looking. Most of the conversation surrounding AI is fixated on the user interface, right?
Yeah, like the chatbot we type into.
Exactly, or the image generator we play with. But our source material forces us to look entirely in the opposite direction. It directs us to look underground at the structural integrity of the whole field.
Which is exactly why you, the listener, directed our focus here. While everyone else is arguing to the exterior paint colors of these AI applications, you are looking at the blueprints, the academic research papers.
We're real substance.
Right. Okay, let's unpack this. Because before we get into the dizzying speed of the cutting-edge stuff, we really have to establish what this source actually means when it uses the word foundations. We throw that word around a lot, but in Gen AI, a foundation isn't like a line of code.
No, about it.
It's a mathematical proof.
That is the core distinction right there. Yeah. Progress in generative AI just doesn't happen the way traditional software development does.
How so?
Well, think about classical software. You have teams of engineers writing logic rules, debugging code, pushing updates in a closed ecosystem. They are building a product. But the underlying mechanics of generative AI, like how a neural network actually learns or how it processes language, how it generates a completely novel image.
Yeah.
That isn't just coding. It is theoretical mathematics and advanced computer science. The progress happens in academic research papers long before it ever reaches a commercial product.
So the paper is the actual mechanism. When an application generates a mind-blowing result, it's not because a programmer just typed really fast on their keyboard.
Right.
It's because an academic paper proposed a fundamentally new mathematical architecture for processing data.
Think about the actual anatomy of one of these research papers. They usually appear first on preprint servers, like ours here.
Oh, sure.
And they contain dense theoretical models, complex algebraic equations, rigorous statistical proofs. The paper is proposing a new architecture, a new way for a machine to weigh and evaluate information.
Okay, so they map out the theory.
Exactly. And when that theoretical architecture is proven to work, that's when developers take that math, translate it into code, and train models on it. The academic paper is literally the DNA of the software.
Wow.
Without the paper establishing the theoretical method, the consumer app simply cannot exist.
Which brings us back to our city analogy. If Gen AI is this rapidly expanding, futuristic metropolis, these applications are the skyscrapers. They are the shiny glass facades everyone looks at.
The one's making all the headlines.
Right. But these specific research papers are the deep underground concrete foundations. They are completely invisible to the average user. I mean, nobody interacting with a chatbot is thinking about the underlying neural architecture.
I'd be very surprised if they were.
Yeah, exactly. But those theoretical blueprints literally hold the entire skyline up. If an enterprise developer wants to build a massive new platform, they don't start from scratch. They build directly on top of the mathematical foundation poured by one of these papers.
And that leads us to the critical dynamic of this field. In traditional architecture, a foundation is designed to last a century.
Here, you don't swap it out.
Right. And even in traditional software, foundational protocols like HTTP or TCP/IP have been the bedrock for decades. They are static, they're settled. They provide a stable environment for everyone to build upon.
But hold on. If these Gen AI papers are the foundations, are we talking about a permanent bedrock? Or is the foundation of Gen AI something that is constantly shifting beneath our feet?
To answer that, we have to look at the specific classification of the research papers, or source material highlights. The text is laser-focused on a very particular category, so SOTA.
State of the art.
State of the art. In the artificial intelligence research community, that acronym is everything. It is the sole metric of meaningful progress.
But we hear state of the art used all the time in marketing, right? Like a company will sell a state of the art toaster.
Yeah, totally.
But in academic research, particularly AI, it's not just a subjective marketing term, is it? It's a highly specific quantitative achievement.
It is entirely quantitative.
Yeah.
In AI research, there is this massive culture of benchmarking. There are standardized tests and data sets.
Like what?
Things like MMLU for language understanding or various benchmarks for image recognition. So when a research team publishes a new paper, they aren't just saying, hey, we think this is a good idea.
Right.
They are actively running their new mathematical model against these standardized benchmarks. When a paper is declared state-of-the-art, it means the methodology presented within it has definitively mathematically outperformed every single model that came before it on those specific tests.
It has set the new high water mark. It's not an opinion. The math proves it is the highest level of general development achieved by humanity at that exact moment in time.
Yes, absolutely. It is the absolute peak of current capabilities. It means this specific paper's architecture is the new reigning champion. And in a field heavily funded by billions of dollars of compute power and global talent.
Oh, the stakes are massive.
Exactly. Achieving SOTA is the ultimate prize.
Okay, but here's where it gets really interesting, because I have to push back on this a little bit. There is a glaring contradiction in our source text that we really have to reconcile.
Okay, let's hear it.
The source says these SOTA papers are the foundations of Gen AI work. But how can something be state-of-the-art, which implies it is brand new, the absolute bleeding edge, literally published yesterday, and be a foundation at the exact same time?
Yeah, that's a great point.
Because usually, foundations take years to settle. They are rigorously tested over a long period before anyone risks building a skyscraper on top of them. A foundation is inherently historical, while state-of-the-art implies the exact opposite.
You've hit on the most disorienting, unprecedented aspect of generative AI right there. You are applying a traditional timeline to a very non-traditional technology.
Okay. I mean, in almost every other scientific or engineering discipline, you are completely correct. A breakthrough happens, it gets peer-reviewed, it is debated, it's slowly integrated into smaller projects.
And then eventually accepted.
Exactly. Maybe a decade later, it becomes the unquestioned foundation of the industry. But the cycle of innovation in generative AI is so violently, aggressively fast that the timeline of adoption has completely collapsed in on itself.
The timeline has collapsed.
Oh.
Okay, let's break down how that actually works in practice. What is the mechanism that allows a brand new discovery to become a foundation instantly?
It really comes down to the way the global AI community operates. When a SOTA paper is published, let's say it comes out on a Tuesday, it isn't locked away. It is immediately available to a massively interconnected global network of researchers and developers.
Right.
So by Tuesday night, developers are already writing the code to implement the paper's math. By Thursday, they are running tests.
Wow, that fast. That fast. And by the weekend, they have realized that this new architecture fundamentally lowers compute costs or drastically improves reasoning capabilities compared to whatever model they were using last week.
So they just abandoned last week's foundation completely.
They have to. The competitive pressure is just too high. If a new paper proves there's a drastically more efficient way to process language, you cannot afford to keep building your multi-million-dollar application on the old math. You pivot immediately.
That is wild.
It is. So today's absolute cutting-edge, mind-bending, state-of-the-art breakthrough instantly becomes the foundational building block for tomorrow's work. The bleeding edge solidifies into concrete almost overnight.
Let's look at the most famous historical example of this, because I think it perfectly illustrates what our source material is talking about. Think back to 2017.
Oh, I know exactly where you're going with this.
Yeah, researchers at Google published a paper called "Attention is All You Need." They introduced a new architecture called the transformer. At the time, it was a state-of-the-art breakthrough for translating languages. It was the bleeding edge.
And within an incredibly short window, the entire industry realized this wasn't just a neat trick for translation. The transformer architecture was fundamentally superior for almost all sequential data processing.
It changed everything.
It really did. It didn't take a decade for it to become the standard. The industry pivoted massively. That single SOTA paper instantly became the foundation for BERT, for GPT, which, by the way, literally stands for Generative Pre-trained Transformer,
Right?
and for nearly the entire generative AI revolution we are living through right now.
So the foundation isn't a static slab of stone. It is a living, breathing, constantly updating mesh of new academic research.
Exactly.
And understanding that the foundation is always moving explains exactly why our source material emphasizes its next massive directive. The text doesn't just suggest we passively observe these SOTA papers, it outlines a strict mission, focusing on sharing the papers on Gen AI-related topic.
The concept of sharing is the engine of this entire collapse timeline we just discussed. Because this technology is moving at such a blistering pace, and because the bedrock is constantly being rewritten by these state-of-the-art breakthroughs, progress relies utterly on the open distribution of this complex research.
Contrast that with the old corporate tech model. In the 90s or early 2000s, if a massive tech conglomerate made a structural breakthrough, they certainly didn't publish a highly detailed paper explaining the math to their direct competitors.
Oh, definitely not.
They locked it in a vault, they patented every single aspect of it, hid the code, and built a massive walled garden around their intellectual property. The goal was to hoard the foundation so nobody else could build on it.
Right, and hoarding intellectual property makes perfect sense when you are trying to monopolize a static product. But generative AI is too vast and the compute requirements are too immense for any single silo to solve every problem.
It's too big for one company.
Exactly. The open source ethos, this deliberate sharing of state-of-the-art methodologies, is what accelerates the field. If a researcher achieves a major milestone in reducing hallucinations in language models and they lock it away, the global community wastes millions of hours and billions of dollars trying to recreate that same math.
But by publishing and sharing the paper on open platforms, they allow the global community to immediately use it as a new foundation. A researcher in Paris publishes the breakthrough on Monday, a developer in Tokyo implements it by Wednesday, and a startup in Silicon Valley builds an app on top of it by Friday.
It's breathtaking.
It is. The open dissemination of these SOTA papers is the sole reason the technology is advancing at a pace that is, frankly, hard for the human brain to track.
Which brings us to the operational reality of our source text. When it mandates sharing the papers, it isn't just talking about the researchers themselves. It is talking about the ecosystem of knowledge surrounding the research. It is talking about how we process this fire hose of information.
So what does this all mean for you, the listener? Because let's be totally honest here. Raw, unfiltered academic research papers can be incredibly dense.
Oh, they're brutal to read.
They are, packed with complex equations, highly specialized mathematical jargon, abstract theories. If someone just dumped a stack of 50 fresh Gen AI research papers on your desk and said, hey, here's the new foundation, it wouldn't be empowering. It would be paralyzing.
It would be entirely counterproductive. You would spend all your time just trying to decipher the Greek letters and the formulas rather than understanding the fundamental implications of the technology. The goal isn't to turn everyone into an AI research scientist capable of writing a neural network from scratch.
Right, so the act of sharing highlighted in our source material, it isn't just about mechanically attaching a PDF to an email or posting a link to a preprint server. It is about the vital, necessary importance of translation and curation.
Translations are the perfect word for it.
Yeah. The mission is about highlighting the most critical state-of-the-art knowledge, distilling the heavy math into fundamental concepts, and disseminating it in a way that learners everywhere can actually grasp the foundations without needing a PhD in computer science.
The source text implicitly recognizes that sharing must be an active, deliberate process of decoding. It is about creating a bridge between the highly technical academic world that is pouring the new concrete and the broader community of professionals, learners, and builders who need to understand how the city is being constructed.
Exactly.
By focusing on sharing these specific SOTA papers in an accessible way, the shifting bedrock becomes something you can actually map.
It's essentially acting as an incredibly skilled tour guide for the underground architectural blueprints. We take the math and explain the mechanics. We explain the HOW and the WHY. Why does this new architecture use less memory? How does this new method allow an AI to generate video instead of just text? It empowers you to look at a mind-bending new AI app and say, I know exactly why that works. I know what mathematical breakthrough from 3 weeks ago made that feature physically possible.
And that is the ultimate strategic advantage for anyone trying to navigate this space, whether you are an investor, a developer, or just an intensely curious learner. When you understand the state-of-the-art foundation, You're no longer surprised by the applications built on top of it.
That's a great way to look at it.
The shiny skyscrapers don't look like magic anymore. They look like the logical, inevitable result of the math you already studied. You can anticipate the trajectory of the technology because you are watching the ground being prepared before the building even goes up.
I love that. You stop reacting to the skyline and start predicting it.
Exactly.
So let's bring all of this together and distill this deep dive down to its absolute core takeaway. Our grounding source today was incredibly brief. It was just a single, focused mission statement regarding the foundations of generative AI and state-of-the-art research. But the concepts packed inside those few words dictate the pace of the entire global technology sector.
The core realization here is that the rapidly evolving state-of-the-art research papers are not just theoretical academic exercises filed away in university libraries. They're the essential, constantly shifting foundations of all Gen AI work.
The actual bedrock.
Yes, they're the invisible framework dictating what is literally possible.
And crucially, the source highlights that focusing on sharing them, translating, curating, and disseminating this dense, bleeding-edge knowledge is the only way to genuinely understand the field. For you, the listener, keeping your focus here is a superpower.
It really is.
By paying attention to the translation of these foundational soda papers, you are effectively skipping the endless hype cycle. You aren't wasting your time reacting to a marketing press release about a new chatbot. You are going straight to the source code of the future. You are honoring your preference for thorough, efficient, fundamental learning.
It is the defining difference between being a passive consumer of a technology and being an informed observer of its evolution. By understanding the soda papers, you understand the very physics of the Gen AI universe. You understand the mechanics of the possible.
Which brings us right back to where we started. The next time you see a massive, impossible new AI capability hit the news, don't just stare at the shiny skyline. Remember to look down. Think about the invisible foundation, the brilliant, complex mathematical architecture that was just poured to hold it up.
And remember the collapsed timeline. Someone, somewhere in the world, is already running the benchmarks on the paper that will replace it.
So true. So as you step away from this deep dive and go about your day, I want to leave you with a final, lingering thought to mull over. If the state-of-the-art in Gen AI research is changing almost daily, how often is the very foundation of this technology being completely rewritten right beneath our feet?